Java is an object-oriented programming language, meaning it's built upon the concept of something called an object. And to really understand what these objects are, we first have to make sure we understand what a class is. We see a class right here on our screen, this automatic one that got made called newClass. It's public, meaning that it's viewable by everything in the project, and it's a class called newClass. It looks a little familiar. It's kind of like a variable, the type, and then the name. So that's consistent with other things that we've seen. And when we've been working with variables before, well, we have a few different types. We have our int, like num. We have our double, num decimal. We have our booleans, true or false. We have our strings are the kind of where things get a little bit problematic. We have this capital S on our string, and that differentiates it from these other variable types above. If you recall, these variables are called primitives. Primitive means that they really are just quite a simple data type that's not meant to be anything particularly fancy. If I type a dot after this num, I see some things being suggested to me, but actually let me go down here, num dot, and nothing happens. I actually don't have any special functionality inside of a primitive. It's very, very simple. Oops, let's get this spelling right. And, well, primitive. There's a reason for the term here. However, a string, when I make it and I press dot, I see a huge list of different behaviors all of a sudden appear and pop up. These are called methods. They are all of the different behaviors and actions that we can perform with strings. They're much more complicated things that we call objects. And there's much more, or many more objects than just strings. In fact, it's the main building block of Java. There's very few primitives. I guess we also have a char that we can work with char, and we had a few other types of whole numbers and decimal values, but really the primitive list is pretty short. But this object list, I could fill this with millions of examples. What's another example other than a string that I could pull up here really quick? Well, one that we've used pretty recently, our scanner. Scan equals new scanner, system.in, and I'm going to import the scanner here, got it imported up at the top, and this scanner is an object. How can I tell? Because if I go scan dot, it has a huge long list of methods that I can actually have perform some functionality or return some value or process some information for me. The main way of knowing is this capitalization at the start of the data type. Primitives are lowercase, and classes that make objects are uppercase. Another way that we can kind of tell that things are happening in that way is whenever we see this equals symbol and with the new. So with a string, now I did show you before that strings are a bit weird. I can actually just type in something called a string literal, my message, and that works for strings. But every other type of object actually has to have this new statement. Strings actually work that way as well. Phrase2 equals new string, and then inside of it I can have new message. Why can I do this with the string? Well, the simplest answer is that we use strings often enough that Java built in a shortcut way to not have to type all this in, just to save us a little bit of time. Really, there's something else going under the hood too, but for now that's really a sufficient explanation. So what is this scanner? Well, it's a class. It's a blueprint for how the scanner is supposed to work. And what's included in this blueprint? Well, I can kind of get a peek at it by just typing in scan, pressing dot, and seeing all the different things that it can do. And let's say I choose this has next. I'll see this Java doc, which is a description of how this works. It returns true if the scanner has another token in its input, and a little more information we can worry about later. So it has a bunch of different functionality and behaviors. Okay, so we can access other objects, and we've used the scanner before to do things like next int, for example. I could also pull in another class that's been pre-made by Java, a randomizer. And I'm going to say a new random, and I'm going to hit Alt-Enter to import this randomizer. And now I have another object, this random object that can do all these different things like get a random integer. And now I've been able to access some new functionality. So a class is a blueprint for a series of behaviors, and an object is the thing that I actually create in my project that allows me to access those behaviors. It's basically a version, an implemented version of this blueprint. The implementation process, we call this instantiation, creating an instance of the randomizer, or the instance of the scanner, instantiation. We're not only limited to using classes created by other people, we can make as many of our own as we want, and it's often a really good design choice. Here's how we do so. Well, we made one from the very start. In this tutorial project I'm working in, I can go back to this package I made and go new Java class. And what if I call this class message maker? Hit finish, and it's going to create this new class. And up at these top tabs, I can jump back and forth between the classes I'm in. I'll zoom in a little bit here. I sometimes like to clean up this extra information just to have it nice and simple. I have this public class here that I can add some content into. And what is it that I want this message maker to do? Well, in the next tutorial, I'll be showing you more about how to make and work with methods. But one thing that classes really like to have is something called the constructor. This is what sets up its initial state. So what does a message maker look like the moment that it's created? And here's how we make a constructor. We type in the word public and then the name of the class, message maker, with open and close brackets after it. This is going to be run as soon as a message maker is created. And just to prove it, I'm going to have the message maker send it a message. I'm alive. So our class so far is very simple. The message maker can't really do anything other than it can be created and report that it's now alive when it's created. So what do I do with it now? Well, let's go down to my project, and I'm going to kind of back this up here, maybe to here, because I don't need any of that content right now. And this message maker class I can access like any other class. I just don't have to import it like I do some of these other classes because it's in my project. I can literally just go, not new class, message maker. Notice it autofills here. Message maker, I'm going to call it and I say new message maker. And there we go. I've now instantiated an object, which I can now perform some behaviors on if I had any. What can do right now? Well, just a bunch of behaviors that all Java methods can do. Every method in Java can check if it's equal to something else. We can check its class. We can get its hash code, which is basically some numeric information about its contents. And it can do a few other behaviors, like print out some information about itself that all classes can do. But I haven't created any custom content yet. We'll do that in the next tutorial. But the one thing that I want to really see clearly here is if I press run, my code, because I'm running in the main method, it's going to start here. It's going to initialize these variables. It's going to set these messages, and then it's going to create my object. And remember, when I create an object, the constructor should say I'm alive, and right there, I'm alive appears. We've just created our first own custom object from a custom class. And in the next tutorial, we're going to look at a little bit more about how to make our own custom methods.